Welcome to Module 1 of Welding 2, Welding Symbols. Objectives. Upon completion of this module, you'll be able to, number 1, identify and explain the various parts of a welding symbol. Number 2, identify and explain fillet and groove weld symbols. Number 3, read welding symbols on drawings, specifications, and welding procedure specifications. And number 4, interpret welding symbols from a print. All right, let's get into it here. The basic element of a welding symbol is the reference line. Typically attached to that reference line is going to be your arrow. All right, a welding symbol with the ing, a welding symbol, is a symbol used on drawings, project specifications, and welding procedures to convey design specifications for welds. A welding symbol is this entire thing, and we're going to show you a whole lot more stuff that we can add to it here later, but just the difference between a weld symbol is the triangle indicating a fillet, the V indicating a groove. That is a weld symbol. A welding symbol is all this inclusive item here. So you'll have to know the difference between those two definitions for some NCCER and some AWS questions you'll have coming up. So we can add a tail to the reference and arrow here. We got a tail here. What do we put in the tail? Any information that we don't have a symbol for. So we're not going to put the words fillet weld here because we've got a fillet symbol. We're not going to put field weld because we have a field weld symbol. We're not going to put all the way around because we have an all the way around symbol that we can put on that. So what do we put here? We could put a WPS to refer to for the type of weld we're going to have. We could put FCAW for flux core. We could put ER70S-2 for the type of filler metal we need for either TIG or MIG. So any information that we don't have a symbol for goes in the tail. All right, let's discuss arrow and other. Anything in reference on the bottom side of the arrow, arrow line, the reference line, indicates arrow side. Anything referenced on the top of the reference line indicates other side. So notice this arrow is pointing to the same location on this T-joint. However, the fillet symbol on the bottom means the weld goes on the arrow side, and the fillet weld on the top indicates that it goes on the other side of where the arrow is pointing. Same thing goes for V-groove welds. Notice the arrow is pointing on the top, and that's where we welded it from, arrow side. And when the groove weld is on the upper side of the reference line, the arrow's on top, but we want to weld it from the other side. Now you ask why? Why do they do this? Well, for instance, this drawing down here, this weld, this coupon is awful close to the end of your screen. This welding symbol might not fit down here. So when you run out of room on a print, you put that symbol where you need to and distinguish between arrow and other side. All right, now here is the entire welding symbol, ing, the whole welding symbol. Let's take this from tail to head here, and we'll talk these out. You'll have to label something like this, all right? So expect this, know this. This is your craft, so take pride. All right, this is your tail, and that tail is omitted when you don't need it, okay? When there's no reference in it. So here's your tail, and inside the tail goes the T, the specification, the process, or other information, okay? So the tail's pretty easy. Working our way to the right, we come into this S right here. The S is the depth of bevel. That's how far down I'm going to prepare the metal. A good example is on our 1-inch 6010 7018 open root weld test, we only prepare that metal 7/8 down. Now I know you put it on the track torch, you bevel it sharp, right? So you beveled it 1 inch, but then you take it to the grind room and you grind on an 1/8 inch land, right? So that you actually only prepared it 7/8 thick. So if we were going to, now inside these parentheses, this E, that is my groove weld size. That's the size of the weld. So on our 1-inch stick plate test, I would have a 7/8 here where the S is, and I would have a 1 inch in here where the E is. All right? So on the outside of the parentheses is the depth of bevel. On the inside of the parentheses is the depth or the amount of weld. All right? Moving along. These parentheses here indicate where the weld symbol goes. No ing there, just the weld symbol. So a triangle, a V, a U. These are the different grooves. Maybe just two parallel lines indicating a square groove. but that's where your weld symbol goes. It can go on the top for other, go on the bottom for arrow, or if you put it on top and bottom, that means both sides. All right, now let's jump down first because that'll be easier. N. The N means the number of welds. So if I'm giving a length and a pitch, maybe, a staggered type of weld, maybe I'll have a number. So if this is a 2, I only want 2 welds. If it's a 6, I only want 6 spot welds or slot welds. All right, so that's a quantity. Bouncing back above, the R. So this root opening it squeezes in between the weld symbol. So if you picture a big V right here for a V groove, all right, that R would say 1/8 for an 1/8 inch root opening. Pretty easy to remember, R for root opening. A is the angle, all right, so that's the angle of our bevel or our groove. So that's going to be pretty easy to pick out in a lineup. It's going to have a degree on it, 30 degrees, 60 degrees, 75 degrees, so not too hard there. Contour symbols, we've got 3 of them. This one is a flat or a flush. We'll also have a convex, bubbling away, and a concave, caving in towards our weld symbol. And then how did we finish it? So we've got a contour, which is the finish we want, and then how did we finish it? That F is going to be just another letter. It could be H for hammering, C for chipping, M for machining, R for rolling. So there's some examples of how we could finish to get the contour desired. Length of weld is the L, and P is the pitch. And pitch is the center to center spacing. So you want to know that. Definition will be what is center to center spacing on a weld symbol? Pitch. We got a field weld symbol, the flag. Doesn't really matter which way it blows necessarily, and it's typically colored in, but it could be up, it could be down. The weld all array round symbol, circled at the kink of the arrow and the reference. And then there's your arrow line we've already talked about. I want to point out one important thing. When we flip this, like it's possible you see this arrow point up or point down. You might see the arrow on this side and the tail over here. What's beautiful about the weld symbol is, the welding symbol, nothing else changes. My size always goes to the left. My length and pitch always goes to the right. Okay, so you don't have to worry about that. Now if my weld symbol is on the bottom, then these things, root, angle, contour, and finish, they will go with wherever the weld symbol is at. But as far as if we drew a line straight down this thing, everything on the right, length and pitch is always on the right, and the size, depth of bevel or groove, always goes on the left. So that'll make it a little bit easier for you as we tour the landscape here. Don't need to talk much about this other than, yes, so CWIs also have their own weld symbols. So you might have, maybe a UT or an RT for the type of exam, VT for me, and then the number of examinations, but not as cool as, not worth talking about on a slide here. Groove weld, so these are the types of pictures you're going to see, again, above or below the reference line. You're going to see these types of symbols, all right? So if they're 2 parallel lines, square, a scarf, 2 diagonal lines, a bevel, a flare V, flare bevel, V, U, J, all the bevels we've talked about before. Some other welds, a fillet is a triangle. Notice on the triangle, the perpendicular leg is always on the left. The hypotenuse is always facing the right, okay? Plug and slot, stud, spot or projection. Seam is a circle with 2 lines through it. I think that's on one of your quizzes maybe coming up. Back or backing, back or backing. And you'll want to know the difference there. Which one happens first? ING happens first. You take a backing strip test, put the backing strip on. A back weld happens last, so ING first. Surfacing. All right, so if we drew a weld symbol for U padding plate, you would have these, surfacing, and then there's your edge weld. The 5 basic weld joints. There's 10 up here, but there's 5 basic ones, and unfortunately, this flange, the lineup isn't very true here. So I'm going to grab edge. I'll start with edge. Here's basic weld joint number 1 is an edge, a butt, a corner, a lap, and a T. The most common for the fillet are the T and the lap, and then groove weld. We could groove weld any of them, so don't go wrong there. But and then the flange or the flare is just alterations of those 5 basics. Arrow and other again. Of course, this slide shows you the example of both arrow and other. You know, you'd say that you call that a double fillet or a double V. All right. All right. So what happens when the arrow is kinked? When we put a kink in the arrow, wherever the arrow is pointing, that is the coupon that you have to prepare. All right. So typically speaking, you kind of get your choice on a bevel. If the arrow is just pointing straight, you can bevel the left, the right, nobody cares. But when we kink it, that is the engineer, the architect, whoever designated which piece has to be beveled. All right, and there is a question on one of your quizzes coming up that is like this. It's pretty tricky. They're going to put that symbol on the top maybe. So not only is it kinked, so you got to think, yeah, this side, but if it's on the top, that means other. So the dots have to reference from the bottom to make that appropriate. So watch for that. Attention to detail, right? That's your trade. You're a welder. Couple symbols here. So what they do, it doesn't tell us which one they did first. Maybe you did this fillet on the other side first. Maybe went ahead and welded that. You definitely have a bevel groove to fill and then a fillet on top of that. So honestly, if we're going to draw this correctly, it'd be one more weld maybe to cap off that bevel groove right there. All right, what did we say always goes to the left of the weld symbol? To the left is always the weld size. So in this case, it's a fillet. So we're talking about the leg size. So it's a 1/4 inch wide leg fillet, and that fillet is arrow or other. You tell me. It's on the bottom, so yes, that is arrow side. If we don't have any dimensions to the right, look at that. That's what it's saying here. There's no dimension to the right. So that means we're going to weld this thing the full length. All right, so a welder, you kind of got to pull them back. If I don't tell you how much to weld, you're going to weld it all. All right. So now I've got a number to the right. So now I need a 1/4 inch wide. This is the size, fillet weld, and it needs to be 6 inches long. Skipping this one. All right, here's an unequal leg size. So one of them has to be 1/4, one of them has to be half. The blueprint should indicate which is which. Now, if you can kind of notice that the vertical member here looks a little thinner than the horizontal member. So if they didn't tell me, I would assume, personally, I would assume that you'd want more weld on the thicker member. All right, but luckily here they've called it out. So I need the 1/4 inch. It shows you the height of the 1/4. So then with the 1/4 on the vertical, that must mean they want, by default here, the 1/2 inch on the horizontal member. And that is a fillet symbol on the, so which side of the T do they want this on? The fillet's on the bottom, so they want that on the arrow side. All right, we have stitch welding, or skip welding they call it. A lot of different slang, I guess. We have intermittent, and they call this intermittent chain welding. So it's staggered evenly as we have it. And where I shouldn't say the word staggered, because down here we have staggered, it's alternating. So staggered intermittent versus regular intermittent. And this is a way to reduce the heat, the stress, the distortion, or in some cases it's just a waste of time and effort to weld it all. If you're on some Corn Pro trailer or something like that, you don't need to weld the whole dang thing. You're just holding sheet metal to square tubing. So some intermittent welding would be fine. Notice how we draw it. If we want the intermittent fillets chain welded, perfect. We stack those fillets directly on top of each other. And you go ahead and put that length and pitch. And honestly, you only have to put it on, you probably want to put it on both sides because, hypothetically, I could, on that other side here, I could go ahead and weld that thing solid. So I'd want to personally put my 2 and 6 on both the top and the bottom. Now the staggered one, it wouldn't make much sense. If I'm staggering, then I would only have to list it on one side. That would make more sense to me. 2-6 means I'm making 2-inch welds. Notice how long, 2-inch welds, 6-inch center to center. Now the question you got burning in your head is, well, how far apart are the welds? So it's a little easier to see up here. And all you do is you take the 6 minus the 2, and you should have 4 inches between each weld. But that's typically not how we lay this out, okay? So if I'm a fab welder here, I'm gonna lay this out. I'm gonna go ahead and find the center of my trailer, or whatever this piece is, right? So she's about 18 or probably 20 inches long, right? So I'm coming to the 10 here, and I'm gonna drop 3 and gain 3 and put my center mark. And because they're 2-inch long welds, once I find that center mark, I'm gonna add 1, subtract 1. And then I'm gonna go 6 inches from the center, add 1, subtract 1. And I'm gonna get with soap, I'm gonna soap the start and stop of my MIG welds here. All right, to make that nice and clean, a pretty fabricated project there. Depth of groove is shown like width of weld, but no size is needed if the preparation is all the way through. So again, I don't need it. When you lack information, when you lack a size, you assume prepare it all, weld it all. Depth of groove is shown like the width of weld, but no need for size if the preparation is all the way through. So depth of groove and bevel, either way. So here, I'm going to have a depth of bevel here. It's 1/4 inch. And then if I don't tell you how much to weld, you're going to weld it all. So you're going to penetrate through that and probably give me a melt through, but we'll show you a melt through symbol here in a second. All right, so here's what we talked about before on the depth of preparation, right? Depth of groove. This is how far I prepared it. I beveled it 1/4 inch down, but I'm going to fill it roughly 3/8 deep. I'm going to bite past the preparation there. So I put the size of the weld in the parentheses, put the size of the depth of preparation there outside. All right. Now, what do I squeeze in between my weld symbol? I squeeze the root opening. So it's going to fit inside. This is a double V, I'm showing you right there, and the 1/8 inch. I only have to put it on one side or the other because they're both going to share the same root, right? And then just past the root opening, I'm going to put the angle, and you're going to be able to tell that because it's got the degree symbol, so it shouldn't be too hard to figure out there. Typically, we give that in the groove, the total. We don't give a bevel. Obviously, you got to, in order to prepare that, you have to cut that in half and do 22.5, 22.5, gives you the 45 total. Sizing for dimensioning plug welds, same type of thing. They're going to give you a size here, maybe the diameter, depth of fill. So inside the plug weld, they're going to tell you how much they want you to fill it up because they may not want you to fill it all the way full. The angle, in case it's a contoured, and then the pitch. So how many, or the spacing between each of those, center to center. Slot welds, same way. Depth of fill goes inside. And here they're using some blueprint measurements that size those out, 7 inches apart, 2 inches off the edge there. And here they're giving the size of the hole, 1 inch and then 3.5 inch long. All right, order of operation. So we can stack all the arrows, or you can have you can have multiple arrows, or you can have one arrow that has several reference lines on it, and you always work from the inside of the arrow out. So it doesn't matter if it's pointing down or up. You start at the arrow in the first operation, then the second. See, we start at the arrow, first operation, second, and then work our way out. All right, so here we've got a weld all the way around symbols. Well, this is let's go ahead and get this. A V groove, arrow side. We're going to weld all the way around. And then we've got, after that's done, looks like we're going to ultrasound it all the way around, okay? Here we've got a U groove, arrow side, field weld first. And then we're going to back gouge and do that back weld, also in a U groove, other side in the field. A flag is placed where the arrow meets the reference line. This indicates that this weld is done in the field at the time of construction, not in the shop in your jack stands. Supplemental weld symbols are used to convey special instructions about the welding symbol. So these are extra descriptors about the weld symbol. So weld all the way around, field weld, melt through. You have a half moon, it's colored in. So remember, the half moon that's not colored in is a back or backing weld. But a melt through is colored in. That indicates we want full penetration. We want an 1/8 inch root reinforcement on the back side. Consumable insert, backing or spacer. And if we're going to remove the backer strip, we're going to put an R inside of that. And then we've got our contour, flat flush, convex, or concave. There you go. There's your weld all the way around symbol in action there. Fillet weld, arrow side. There's your field weld symbol. Again, the flag can be up or down, and it can blow left or right. Should be a triangular flag, though. Don't draw any square American flags. All right. So let's break down a couple more examples here. So we have a V-groove, arrow side. We're going to finish it flush by machining. All right, our next example, we have a fillet weld, concave, so we want it slicked in there, and we can finish that by grinding it. All right. All right, here we have the types of finish, and they're just letters for abbreviations here. C for chipping, G for grinding, H for hammering, M for machining, R for rolling, and U for unspecified. All this was in your symbols packet. We've just breezed a lot of these other weld symbols. The amount of reinforcement required on a print is placed to the left of the melt-through symbol. So let's talk specifically about the melt-through. We always talk about size going to the left. So if I wanted an 1/8 inch root reinforcement, I would put an 1/8 next to this melt-through to indicate how much I wanted to pop out the back side. Just showing you a basic backer strip test and what that might look like if we symboled it out there. Now here in the tail, they're indicating the base metal, A36 mild. That says metal strips. Okay, A36 metal strips, 3/8 by 1 inch. So there you go. 1/4 inch wide opening, 45-degree groove. So we're going to have to go 22.5 on each of those. We're going to put a backing strip on there, and then remove it when we're done welding. All right, so we've got a back weld, which means that's done after we get the front done. So we're going to do this arrow side first. 30-degree bevel, 60-degree groove, 1/8 inch reinforcement on the back weld. So if you just put that symbol there, the half moon empty, it could be back or backing. How do we know which it is? Well, they would tell you in the tail if it was done first or done last. Now here they didn't tell you, but order of operation tells us that we're going to do it. You're going to do the arrow side, V-groove first, and then the back weld last. It's a square groove. All right, doesn't tell us the root opening, so slam it shut, I guess, and then punch it through, a melt through with a 1/16 root reinforcement. Surfacing. Notice they had to indicate that we do axial. Typically, we always do radial. When you think about welding around pipe, you think about welding around pipe. Here, they're building up some sort of piece of pipe or shaft or something like that cool, so they did axial. Axial means, parallel with that pipe. That's not common. So if we don't tell you, you're going to do radial. Too small to read. Edge welds, just as cool as the rest of them. Then you get your flares. Again, same symbols. Spot welds. So we have the size of the spot weld. Sometimes we give you the strength even, given to you in newtons or tons or whatever measurement they're given there. But spacing or pitch, again, number of welds. In the tail goes the process. They were resistance seam or spot welding over here, TIG welding here. There you go. There's a spot weld there, a projection weld with the 100 newtons or 300 pounds per inch there of shear strength. You got your pitch spacing, so the center is 4. The number of welds is 8. Pretty cool stuff. I don't know how often you're going to see stuff like this. This is probably factory type stuff. You're not going to be doing much seam or spot or projection welding. Here's a seam weld. You will have to identify one of these, I think, on an upcoming assessment. So a circle with 2 lines, that's important. Weld width always to the left, length and pitch always to the right, and in the tail goes extra information. Oh, that wraps up welding symbols. Now, I would caution you, before you take the quizzes for the AWS, the NCCR, you are definitely going to want to work your way through our weld symbols packet and be very good on that. We have two little quizzes that we've created that should help you understand or predict your success on the NCCR and AWS tests. So I would beef up on that and be prepared, because it is not an easy test. Good luck.